Alrighty. Well, we might as well do mirrors first. Let's do mirrors. In a flat mirror, what is the line perpendicular, or the imaginary line perpendicular to the mirror called? The normal. It should be right in your notes. Nothing new there from what you watched. So this is called the normal. When you talk about a mirror, if you had to describe the mirror in just a couple words, how would you describe a mirror? It's what? All right, they're shiny, right? Shiny, smooth surface. When you guys get into physics, you'll talk a little bit more on the mirrors and the lenses. We're just going to do some introductory stuff here. So we got a smooth, shiny surface. And what is really the big deal about a flat plane mirror? What's its claim to fame? Well, yeah, it reflects. I'm not going to disagree with that. I pretty much in the lecture you guys watched sometime last week made pretty good note of this. Something really special about a flat plane mirror. Not necessarily. Open up your notes to mirror. Should be one of the key things on there when it talks about a flat plane mirror.
Does that do the angles?
Yes, it does.
The incident angle is equal to the reflection angle.
All right, so we got the incoming ray, which is the incident. And then we have the reflected ray. And the angle these two rays form to the normal. So this is the angle of incidence, and this is the angle of reflection. Those two angles have to be what?
Equal.
They got to be equal. So the angle of reflection equals the angle of incidence equals the angle of reflection. How many of you guys play billiards? Shoot pool. You use this all the time. When do you use this relationship?
To bounce off the balls?
Not so much the balls, but the ricochet or bounce off the bumpers on a pool table. Because you know the angle that the ball strikes the bumper is the angle that the ball is going to come off the bumper with. So the angle of incidence equals the angle of reflection. It's probably the big thing to get out of that part for flat plane mirrors. Anything else to add to that one? Again, when you get into physics, you'll get into a lot deeper. Anything else to add to that? Yes, no? All right, let's look at the next one. What type of mirror do we have here?
Concave.
What type?
Concave.
We have a concave mirror. Again, think of a spoon, if you will. On a concave mirror, where is the focal point?
Right where that guy is.
Yeah, right in front of the mirror. At the focal point, what can you say about the image?
Right side up. Upside down.
Yeah, right as you get to the focal point, really the image is upside down. The top ray now becomes the top ray becomes the,
Bottom right.
and the bottom ray will now become the. What happens to the image when you're inside the focal point?
It is right side up.
True, but what else? Come on, ladies. You should know this one especially.
Magnified.
Because if you got compact mirrors, makeup mirrors, those are all concave mirrors. So they slightly magnify the image. If you have one, my wife's got one, yada yada, so you put on your makeup, it's slightly concave, so it slightly magnifies. And that's probably the big deal on this. on a concave mirror. You get slight magnification when you're inside the focal point. Are we good with that one?
Yes.
Again, I'm just reiterating what you guys already saw. All right, let's do the next one. What type of mirror we have here?
Convex.
A convex. Who's taking driver's training? Who's ever been a passenger in an automobile? Really? Some of you guys have never been a passenger in an automobile. Cody, you never sat in the... What do you notice about the passenger side mirror?
It says objects moving closer to the mirror.
Why?
Convex.
And what is a convex mirror? What does it give you?
Greater field of vision. Or you can see more.
Okay, yeah, you get a greater field of vision with a convex mirror. If you go to I don't know, you go to drugstore, Walgreens, or any of those, a lot of times they'll have them in the corners of the room, so you can see around. Actually, they're anti-shoplifting mirrors, is what they are. Truck mirrors. Anytime you put those circular mirrors on that are, again, bowed outwards, that way you get a wider field of view. But the image itself, is it increased or decreased? Slightly what? Decreased. You suffer a little bit on size of the image to give you a wider field of view on there. Anything else to add to that? A wider field of view. Very good. And again, this is all review, hopefully. It should be. Oh, wrong way. What type of lens? Come on, guys. What type of lens? A convex. Convex lenses are mainly used for what? Magnification. When I was a little bit younger than you guys, I would take a convex lens, magnifying glass, burn ants or grasshoppers. See if we can get them on. What? Oh, we just see if we could start them on fire. Oh, that's just kind of what we did. Magnification. Your eye is a convex lens. As we know, when light goes from one surface to another, one substance to another, it's either going to gain speed or it's going to decrease. And every time you have that, the light does what? It bends. Yeah, changes direction. Yeah, changes direction. Your eyeball is one of these. What's this surface sitting back here on the interior eye called? That's the what? On the retina, where you have the cones and the rods. Your eyeball wants to take the light and focus it on the retina. If you have corrected vision, what happens is they put either be glasses or contacts. They're adjusting this focal point to put it onto the retina. And it's usually some combination of convex and concave lens, and put it on to the right on that retina near the fovea. And then that gets it to the optic nerve, which gets it to the brain. So main thing here is you have magnification. Okay, what's the other one then? These people, this isn't all that hard. Concave. What does this do to light? Yeah, instead of bringing it together to a focal point, it does what? Spreads the light out. So when you have a concave lens, you are moving the light, separating from each other. Typically, any type of optics, binoculars, telescopes, whatever, microscopes, camera lenses, they're a combination of convex and concave lenses. If you have glasses, some type of combination of this to get that light to focus on the retina. If we had more time, we'd probably get into focal length and focal point, but as it is, we don't have enough time. So you guys will get all that in physics. Both those lectures are fairly short. Anything to add to those two? You good with them? All righty, I'm going to turn this off a second.